Okay, so we now need to do derivation 2b for the overdamped case. Okay, so I've written down what's given and what we need to show over in the left-hand column. And over in the right-hand column, you can see what we should recall. The angular frequency or angular velocity with no damping, when you square it, is equal to k over m. And the decay constant, which we're going to get out of this, is b over 2m. And if you're clever, you can see those right in the original expression given for R that we derived in the last video. Okay, so our starting point is to start with R equals negative B plus or minus the square root of B squared minus 4mk all over 2m. Now you can see what we need to show. We need a negative gamma in front, which would be negative B over 2m. So we need that to be our first term, I should say. And so we can break this into negative b over 2m plus or minus the square root of b squared minus 4mk all over 2m. So we simply took the common denominator and split things into two terms, all right? The second term has a plus and minus, so we'll get R1 and R2 out of that. But we can just work with R for now. Okay, so continuing onward, we need to somehow get that 4m to cancel. We just highlight this. When you're doing your proof, you don't need to do that. You don't need to circle anything. We need that 4m out of there because we need a square root of k over m to show up, all right? Or just a k over m because we know k over m is omega squared, all right? So how do we get a 4m out of there? Well, if we extend the square root sign over the numerator and denominator, we can get that to happen quite easily. So let me show that. So that part is, the first term is already where we want it to be. But now we can extend the square root sign over both the numerator and the denominator. And when you put 2m inside of the square root, it becomes 4m squared. You have to put it in twice. So 2m times 2m is 4m squared. Okay, so that gets us a lot closer to what we wanted. Now these next couple steps are not too tricky. Let's now do what we did before. Let's make two terms inside of the square root. Okay, so if I do that, we're getting much closer to the target now. The next step will hopefully make that clear. Remember, from what we were given before, we like b over 2m because we can abbreviate that as gamma, the decay constant, and we like k over m because that's the undamped angular velocity squared, omega naught squared. All right, so let's see if we can create both of those. So when you look at this, b squared over 4m, well, if you rewrite it this way, that's going to be very nice, okay? And then we have minus 4mk over 4m squared. That's just going to be k over m. Now we're ready to do all of our substituting. R needs to be negative b over, whoops, we're ready to substitute, so we don't write negative b over 2m this time. We can go right to substituting gamma for that, okay? Plus or minus the square root of gamma squared minus k over m, that's omega naught squared, okay? So if we look at this, R1 is just going to be negative gamma plus, and R2 will be negative gamma minus square root of gamma squared minus omega naught squared. All right, that's the end of the proof. Just a couple quick notes here, okay? You'll notice that this is going to be negative, but this will be less negative. This is not part of the proof, what I'm writing in yellow. I just want you to realize this. This will be more negative. So if you put it all back into the general solution, that x is equal to c1e to the r1t plus c2e to the r2t. Since the second one is more negative, this term dies faster. This dies quickly. Okay, so in the very short term, the C2 term matters, but if you ignored it, you would get pretty close to what the actual solution is, because the C1 term is going to die off less quickly than the C2 term. So that's what you have there, but the solution, the proof stops right there. But remember what the general expression was. It was what I have below in yellow. So both of those terms are going to involve exponential decay because R1 and R2 are real. And they're both negative. So we have exponentially decaying terms.